In this problem, a stone is fired from a catapult upwards. Its displacement is given here by this formula in meters and in seconds. We need to find the velocity and the acceleration function for the stone and draw its sign diagram. It's important to note, because we have a vertical upward motion, that acceleration is a given in these cases, because the acceleration is due to the gravity, and gravity here will be 9.8 meters per second. And it is also important to realize that velocity and acceleration function are vector functions, and therefore they not only have magnitude, but they also have direction. The direction is indicated by a negative sign, and mostly we decide whether we want to make a direction to the up or down or right or left. Finding the velocity function is done by differentiating the displacement function. Using the principles of differentiation, we will have 98 minus 9.8t. So this function gives us a very important information, because it tells us that when the velocity is 0, that means that there will be a change in direction. It means that the particle has stopped and now it will be going in another direction. And this will happen when 0 is equal to 98, take away 9.8 t. And we'll find that that happens when t is equal to 98 divided by 9.8, which will be 10. And the time is in seconds. And so as we draw the sign diagram for a velocity, we are reminded the fact that this means that time has to be greater or equal to 0. In that case, we start with 0 and we put a little hatch over here to say that we do not require time to be anything less than 0. Now we're told that the velocity changes signs at 10 seconds. So what we want to do is find the sign between 0 and 10. So substituting a number between 0 and 10 into our velocity function, which is over here, will give us a positive result. This means that as we throw the stone upwards, its sign will be positive in the upward motion, and when it comes down, we substitute a number between 10 and 11, say for instance, and we find that the result will be negative, which means that the direction of the velocity is going downwards. This means that if we started at ground here as 0 and the stone is thrown upwards, the velocity therefore is positive, and right at the top over here the velocity will be 0, and it is positive on that side and negative when it comes down. So using differentiation, we look at that velocity function and we differentiate the velocity function to get the acceleration function. And using the principles of differentiation, all we get is a number called 9.8 meters per second squared. And the number is negative, so we can now draw the sign diagram below here. And once again, our time is going to be positive, so it'll be always above 0. It'll always start with 0, and the sign diagram for here will be negative throughout. Please make sure that you label the sign diagrams. This one here is for velocity, and this one here is for acceleration. Although this is not part of the question, I will show you that this part here, where I'm shading it yellow, and both signs are negative, indicates that the speed is increasing. And the other side, where the signs differ, the speed is decreasing and increasing on this side. Now we're asked to find the initial position and the velocity of the stone. That happens when time is equal to 0. So the displacement of the stone at time is equal to 0 is 98 multiplied by 0, take away 9.8 multiplied by 0 squared, which simply means it is 0 meters. So what would our velocity be at that spot when time is 0? Our velocity is going to be 98 take away 9.8 times 0, and that will be 98 meters per second. And because it's a vector, it's important that we say that it is upwards, because we need to know its direction. And of course our displace was on the ground. To describe its motion, we need to know the displacement, the velocity, and the acceleration at both of these times. And so at t is equal to 5, I'll just rewrite those three equations here to the side. 5 seconds, it'll be 98 times 5 minus 4.9 multiplied by 5 squared, which is 367.5 meters above ground. And the velocity at 5 seconds will be 98 minus 99.8 times 5, and that will be 49 meters per second upward, skyward, to the right. And acceleration, well, at any time will be minus 9.8 meters per second squared. And since velocity is positive and acceleration is negative, we have a decreasing speed. Now the calculations are done, but we need to describe this. So we will do this by saying at time is equal to 5 seconds, the stone is 367 meters above ground, and it's moving upward at 49 meters per second with a decreasing speed. Now let's look at time is equal to 12 seconds. Simply inserting it into the formula, 98 times 12 minus 4.9, 12 squared, and we should get 470.4 meters above ground. Velocity at 12 seconds will be 98, take away 9.8 times 12, and we will get negative 19.6 meters per second. And what does the negative sign mean? It'll mean that it is moving towards the ground. And naturally the acceleration will be the same. It will be negative 9.8 meters per second squared. And since you can see that the velocity at 12 seconds is negative, and the acceleration at 12 seconds is also negative, we conclude that the speed is increasing. And so we will write that at t is equal to 12 seconds, the stone is 470.4 meters above ground, and it is moving towards the ground at 19.6 meters with increasing speed. The maximum height was achieved, if you remember still in question 1, when the stone was at its highest point and changed its velocity. So that happened when time was equal to 10 seconds, when velocity was equal to 0. So by substituting time is equal to 10 into our displacement function, we will find out where it was. What was the height? And this would have been at 490 meters above ground. Now to find the time taken for the stone to hit the ground, if it took 10 seconds for the stone to go up, it'll take 10 seconds for the stone to come down. So altogether, it'll take 20 seconds. I hope that this helped those year 11s who are starting off with kinematics before year 12. So please subscribe to get my further videos, and if you particularly want me to do a problem, please let me know on my email.